Welcome to section 4.8. So this is kind of the big picture of what I've been kind of alluding to whenever I said, hey, we can't square root a negative. Well, this is now finally, you get to learn what that mystery is. What happens when you try to square root a negative? Because if you do it in your calculator is going to get kind of cranky with you. So square root negative 25, ooh, it doesn't like that. Okay? And the reason it doesn't like that is because you'll never be able to take a number times itself to get a negative number. Okay? You know that doesn't work because a negative times a negative is positive and a positive times a positive is positive. There's no way to multiply a number by itself and make it negative. So, because of that little caveat to multiplication, they had to come up with a whole new piece of our number system. Okay? And that piece of our number system is called the number I. Okay? And the number I is set equal to the square root of negative 1. Okay? So I equals the square root of negative 1. So what does that mean for us? Well, what that means for us is now it's an additional piece I can break down. So that square root of negative 25 is actually the square root of 25 and negative 1. Square root of 25 we know is 5. Square root of negative 1 we now call I, an imaginary unit. It doesn't actually exist, okay? It's not a real number like everything else we've ever dealt with in our math career. It is an imaginary unit to let us still perform operations and computations with these values whenever we're trying to square root a negative number, okay? So kind of a unique situation that we have going on. Now, the number negative 8, or the square root of negative 8. So again, what we're talking about is that is 8 and negative 1. Okay? So right now, we have this as square root of 8 times I, but that square root of 8, that square root of 8 can also simplify, right? So the square root of 8 is actually 4 and 2. Again, still with that I. So square root of 4 we know is 2. So we get that, okay? So no, the real part can continue breaking down like it always has and simplifying radicals. We just have to know to take out that negative and call it I. Now, the way that I prefer to write it, okay? The way I prefer to write it is 2I square roots of 2, okay? So you're going to put the whole number piece, then the I, and then the radical piece whenever you're writing these, okay? And it's just kind of common notation, and it just makes it very clear in reading it, okay? So there's a whole number piece, then the I, then the radical piece, all right? Now, again, as you go through, I'm not going to expect you to show all of that work all the time, okay? So for example, for this one, I'm just going to take that negative out right away to call it I, and then I still have the square root of 7 left, okay? So again, there are kind of shortcuts in this as you get better and better at writing these, that I'm not going to expect all of the work all the time, okay? Whenever you have a square root of a negative, oh, boop, pull out that I, and then you just have the rest of it left, okay? So that's kind of the gist of how to simplify a radical that has an I in it. Now, let's talk about how do we solve quadratic equations that have i's in them? Okay, so for all of these, notice there's no b term. Okay, So for these, the method of solving, all I have to do is a square rooting process back from 4.6a. Okay? So a piece of this chapter and what becomes critically important within chapter 5 is distinguishing what can I do to solve quadratics, okay? In this case, I notice every single one of these, they're missing that b term, so that means all I have to do is square root these, all right? So what does that mean if I say I'm square rooting? Well, first of all, it means getting the x squared by itself. So minus the 200. Oh, I'm sorry. Let me start over with that. So 2x squared equals negative 200. Divide by 2. And now I'm ready to square root this. So remember, whenever you're square rooting in an equation, remember you get your plus and minus. Square root of 100 is 10. But then because I'm square rooting a negative, I have to remember to put an I with it. Okay, so again, that's kind of the secret here is whenever you're square rooting negatives, you have to include that I piece in there as well. This one over here, same thing. I don't have that b term, so all I have to do is get the x squared by itself. Subtract the 60 over, divide by 3. Now square root both sides. You always get a plus or minus. Right away, I know I'm square rooting a negative. Excuse me. So because I'm square rooting a negative, right away, I'm just going to pull that I out. Okay, I'm not even going to take my time to show square root of negative 20. I'm just going to pull it out right away. And now recognize that that 20 is actually 4 and 5. So really what my solution is, square root of 4 gives me a nice 2 that I can pull out. So I get 2 plus or minus 2i square roots of 5. All right. Then this one, I'm going to add the 50 over. I'm going to square root. Now in this one, you get your plus or minus, but notice that this time I gave you something that you're square rooting a positive. So because I'm square rooting a positive, this one actually doesn't need the I. This one's different, okay? So don't just assume everything has an I now, okay? Because when you're square rooting a positive, you don't need it. You can just leave it as is. And then of course, that 20 or that 50 can split up into 25 and 2, giving me my final answer of plus or minus 5 square roots of 2. And my next one, subtract the 24, divide by 2. Again, the first goal being get the square root by itself, or the x squared by itself. Now I square root both sides. And here, of course, I do have the negative again. So because I'm square rooting a negative, I am going to take out that I right away, write it like that. And 12 can break up into 4 and 3. So my final answer is going to be 2i square roots of 3, because the square root of 4 becomes 2. All right, now, what method do we know? What if I asked you to solve a quadratic that looks like this? What method did we just learn last section that lets us solve something with all three terms. And I'm hoping you're remembering our friend, the quadratic formula. Okay, so again, very important you know the different strategies. Here, square rooting would not work. Now we have that b term again, so we want to write this or solve this using quadratic formula. Negative b plus or minus b squared minus 4 times a times c all over 2 times a. And remember, we do want to make sure to simplify this radical first. So that piece that's inside the radical, okay, let's type that into our calculator. So negative 3 squared, wait, just making sure, yes, I do want the negative there, minus 4, oh, minus 4 times a times c, and we get negative 31 in there. So we have 3 plus or minus square root, and I just calculated that to be negative 31 over 4. And here, hopefully right away, you're noticing that there's an issue here. We can't square root a negative. So I hope that you notice we never leave it in terms of square rooting a negative. So the way I would write this is pull that I out. And that is how we would want to represent it. We never want to leave them with negative square roots. We always want to represent them in terms of I. So that is what my final answer would look like. Okay, so again, just some exercise in solving quadratic equations that have imaginary solutions. So now let's talk about complex numbers in general. So today we've been focusing mainly on the imaginary part, but a complex number in general is this whole thing. A plus BI, the real part plus the imaginary part, okay? Because some numbers have both pieces, a real and an imaginary piece to them. So here, when you're adding and subtracting these complex numbers, when you're adding and subtracting, what you're getting is simply a problem of combining like terms, just like we did with squares and all of that type of stuff. So literally all you have to do is add the pieces together. Add the real piece, 4 plus 5 to get 9. Excuse me. And add 3i minus 1i to get 2i. And that's literally all that you have to do. Okay? That's it. When you're subtracting, I do urge you to be careful. And I would actually distribute that negative in, distribute it to the inside, because now it'll be harder to forget that negative. So here, negative 7 minus 3 more is negative 10. 2i plus 5i is 7i. So just like before, when I urge you to be careful with negatives, I do encourage you, take the extra second, write it, distributing that in, and then combine your like terms. All right. So thank you so much for joining me for solving quadratics that have imaginary numbers and then adding and subtracting imaginary numbers. Tomorrow we're going to dive into what do we do when we multiply and divide these imaginary numbers. All right. So before we concern ourselves with that though, let's write our summary and then make sure we're coming back ready to do our practice work.